All right, so today, welcome back. We're going to start on 4.3. We're going to focus on quadrants, and this will pick up kind of on what we covered yesterday. So hopefully you watch that video, and then we'll move on, get into some wording, kind of how Delta Math does it, so you can understand that. There will be a Delta Math assignment then today, in addition to watching this video. So the first thing, if I have a point x, y. So keep in mind, yesterday we drew this picture, but if we have our y-axis and our x-axis, and somewhere along this, our point can be in one of these four quadrants. So this bote we kind of talked about, we don't know where the point is. It'll be in one of the four quadrants. Just remember this is quadrant 1, quadrant 2. We usually mark them in Roman numerals, quadrant 3, and quadrant 4. And depending on if the x's and y's are positive, negative, one of each, will determine which quadrant we go to. Okay, so keep in mind, yesterday we also briefly mentioned that the hypotenuse will always be positive. So let's keep those things in mind, and then we'll read this first question, because this is kind of how delta math is going to word it. So it says, if theta is an angle in standard position, and its terminal side passes through the point -9, -5. Okay, so then find the exact value of cosecant in simplest radical form. So if we have our x and our y, I guess that was our y and our x-axis. If it's at -9, -5, that's our x value, that's our y. So -9 is left 9, down 5, somewhere over here. Okay, now that point, we need to draw in this triangle. And the x direction was -9. The y direction was -5, down 5. Now, at this point, we don't know what this side is. Keep in mind, I forgot to show this on our bow tie. Our thetas are always right by the origin. So in this case, our theta would be right here. So let me switch to red. We know this is our hypotenuse. Hopefully you know adjacent is next to, and this would be opposite. So opposite, adjacent, hypotenuse. Now, we are trying to find the cosecant. Cosecant, remember, is the reciprocal of sine. So it matches up with sine. Sine is so opposite over hypotenuse. So cosecant will be the opposite. It will be hypotenuse over opposite. So first thing we need to do is find what is that missing side. So if we think about that, to do that, we will use Pythagorean theorem. So a squared plus b squared, I could have put a right angle in here. Does not matter which one is which. Our -5 can be a, our -9 can be b. It doesn't matter which one's which. All of that will equal c squared, which is c is our hypotenuse. So -5 squared gives us 25. Remember, you need to remember, whenever you square a negative, it becomes positive. Negative times a negative becomes positive. Okay, so 25 -9 squared becomes 81. If we add that together, we'll get 106. We need to take the square root. Square root of 106 will be our answer. Now we can think quick. Can that reduce? It's not divisible by 3. 2 does go into it. If we put 2 in, it'll be 53. So what I'm saying is 106 would break down 2 times 53. Let's see. Can anything go into 53? Not that I can think of. So since nothing go into either of those, no pairs, square root of 106, that's our answer for what the hypotenuse is. Now, we know that the sine is O over H, but in our case, we are looking for the cosecant, which is H over O. So that would be the square root of 106 divided by O is -5. You can either write it like that, or if you prefer, you could put this, or really, it could be right on top like this. All three of these mean the same thing. Okay, it does not matter to me which way you write it. Okay, On to the next one. So this one, once again, if sine of theta equals -5/6 and theta is in quadrant 3, find the tangent. So just like we just did, the last one was in quadrant 3. This one will be as well. It tells us that. We need to be careful. The hardest thing is those negatives. You got to make sure you are taking care of that. So we know this triangle ends up somewhere down here. Quadrant 3. I'll put my theta. Now remember sine. So O over H. So the 5 is the O, the opposite. If I label these, this would be our A, our H, our O. So O is the 5 is over here, and it will be the negative. Remember, the negative can't go with the hypotenuse. So that negative goes on top with the 5, -5. That makes sense because it's going down, hopefully. And meanwhile, this 6, we don't know what it is. So we do know what it is. It's 6. We don't know what the A is. So we need to find what A is, so then we can find our tangent, TOA. Remember, that's O over A. But I need to find what A is first. So once again, we'll use Pythagorean theorem. -5 squared plus b squared, we don't know what that side is, equals 6 squared. We'll get 25 plus b squared equals 36. Subtract 25, b squared equals 11. Take square root, and b will equal the square root of 11. Okay, now, here's where you have to be very careful. If we put that square root of 11 here, it's not just the square root of 11. This is what we talked about yesterday, kind of like an invisible negative. Because it's going to the left, it's in quadrant 3, we know that the x value is negative, so that's a negative square root of 11. Okay, so now O over A, I'm going to do this in red. We would write our answer, so that's -5 over negative square root of 11. If we reduce that, the negatives cancel, so 5 over square root of 11. We can't leave a square root on the bottom. We need to rationalize the denominator. We can do that by multiplying by whatever that square root is on the bottom. If we go across the top, we'll get 5 square root of 11. Across the bottom, square root of 11 times square root of 11 becomes 11. Remember, once again, I can do this because square root of 11 over square root of 11 is just 1. I'm just multiplying it by 1, but now it looks different. And here is our final answer, and that would be what our tangent is for this situation. All right. Now, the next thing I want to talk about is what if we aren't given a quadrant? We just instead know where, or some things that are true about the trig functions. Okay, so to draw this, let me set up our 4 quadrants again. And let's start over here in quadrant 1. So in quadrant 1, we want to examine our sine, our cosine, and our tangent. And the sine and the cosine and the tangent, if we think about it, quadrant 1, both your x and your y are positive. So if everything is positive, your sine, your cosine, and your tangent will all have to be positive. Now, quadrant 2, that is not necessarily the case. Okay, I'm going to keep it in Roman numerals. So, quadrant 2, sine, cosine, tangent. Now, your sine, if we think about it, is your O over your H. So, the opposite side. Since it would still go up in quadrant 2, that's going to be positive. H has to be positive. So, the sine will still be positive. But your cosine adjacent over hypotenuse, since that was to the left, that's negative. Your tangent, in this case, will also become negative because remember, if one of those is negative, it becomes negative. Okay? So if we look at sine and cosine, since one's negative, it would become negative. Now down in quadrant 3, our sine at this point now, it's going down, so that becomes negative. Cosine is still negative because it was to the left. Tangent, in this case, because both of those were negative, negative divided by a negative will make it positive. And then the final quadrant quadrant 4. Okay, sine, it's down, so it's still negative. Cosine to the right will become positive. Tangent, since it's one of each, will be negative. Now, some of you might be thinking, that's sine, cosine, and tangent. What about cosecant, secant, and cotangent? Now, the good news is, since cosecant is the reciprocal of sine, we know the reciprocal means the sign will stay the same. It does not change. And when I say sign there, I mean SIGN, plus or negative. So reciprocals are always the same. They have the same sign. So maybe right below this, I can write that note to myself. So reciprocals have the same sign. Which means I know that sine and cosecant match up. I know that secant and cosine match up. I know that cotangent and tangent match up. So if I know what one of them is, I can always just match it up. It'll be the same. Now, to establish which quadrant these are going to be in, we need to first remember our greater than and less than sign. So that symbol means greater than, more than. In our case, since we're dealing with 0, it will be positive. Meanwhile, this sign would mean less than. So if we look here at this first one, it says sine is greater than 0. So another way to think about that is sine is positive. Meanwhile, cosine is less than 0, so cosine is negative. Where is sine positive and cosine negative? That only occurs at one spot, over here in quadrant 2. Plus, minus, so quadrant 2. I'm going to put Q2 just to show another way to write it. That means the same. If you use the Roman numerals or the number, it does not matter to me. Okay, example 4 here. It says that tangent is negative, less than 0. Meanwhile, secant is positive. Now, another thing to think about, secant matches up with cosine, so cosine is positive. So if the cosine is positive and the tangent is negative, that will occur in quadrant 4. That is the only spot where that occurs. Okay, example 5 now. Cosecant, remember, cosecant matches up with sine, and it's greater than 0, so sine is positive. Cotangent is also positive, so tangent is positive, and the only place that happens is quadrant 1. Next one, tangent is positive. The cosecant, which matches up with sine, is going to be negative. So tangent positive, sine is negative. That would be Q3. And our final one, sine is less than 0, so sine is negative. Secant, which matches up with cosine, is positive. So when is sine negative and cosine positive? And that would be in quadrant 4. All right. If that didn't quite make sense, maybe watch that section again. That is a little bit confusing. But if we use this chart, we can figure out which quadrant it's talking about just by giving us some information. So example 8 here, it tells us which quadrant it's in. And just to double check here, do you see how it says cosecant and it was negative? Let's check if that would be in quadrant 3. Or if quadrant 3 has a negative cosecant. So cosecant, remember, matches up with sine. Over in quadrant 3, that is negative. So that does check out. It makes sense. Okay, so if we're thinking about this, we know it's in quadrant 3. So if we're going to draw this picture, and it's somewhere down here. So if we draw our triangle in, put our theta in place. Now cosecant, we said that one matches up with sine. So sine, remember, sine, so O over H. So instead, this will be H over O, H over O. So that negative goes to the bottom. So that negative goes with the 8. Meanwhile, the square root of 89 cannot be negative, but that goes right here. Okay, the O opposite. So once again, adjacent opposite hypotenuse. So the opposite is -8. Now to find out what our a is, we need to use Pythagorean theorem. Okay, so a squared plus b squared equals c squared. If I square a negative, it becomes positive. Keep in mind, square root of 89 squared, the square root and the square cancel, and we're left with just 89. Subtract that. Take our square root of both sides, and we will get b equals 5. And once again, we have to be careful here. We were putting 5 in, but because it's in quadrant 3, that is left. That will make that a -5. The invisible negative comes in. Now the final thing it asks us to do is find the value of tangent of theta. Tangent TOA, O over A. So O is -8. A is -5. Negative divided by negative. Those will cancel, and we will get 8 over 5 as our answer. All right. One last problem, then I'm done for the day, and you guys can go into Delta Math and get that done. So if we look here, example number 9 says that cosine of A is 5 over 60 square root of 61. Now keep in mind, that is not an okay way to leave our answer. There's a square root on the bottom. We can't leave that as an answer. Sometimes a problem might have that, though, in the beginning. But that's not our final answer, so that's why it's okay. Angle A is in quadrant 4. So if we draw our axes, and once again, we know that this is down here in quadrant 4. So if I put A right there, okay, it's the same as the theta. Everything will be exactly the same. Now cosine, remember, so that's A over H. So square root of 61. And the A side goes right here. So I know we have two A's now, angle A and also the adjacent. This is our opposite side. We need to find what that opposite side is because we are looking for the exact value of sine of A, which that's O over H. Okay, and it says in simplest radical form using a rational denominator. Okay, so to find O, let's start off again, Pythagorean theorem. So we can do A squared, I don't know what that is, plus B squared equals C squared. A squared plus 25 equals 61. We'd subtract the 25. A squared equals 36. Take your square root. A will equal 6. Now I put a 6 here. Is it positive or negative? Hopefully you know it's down, so it's going to be negative. Okay, we're almost done now. To find the sine, remember sine is O over H. So our O, -6 over H, square root of 61. We can't leave it like that because it asks us to have a rational denominator. So multiply by square root of 61 over square root of 61. And we will get -6 square root of 61 over 61. 6 and 61 don't have a common factor, so we are done. All right. Hope you guys have a great day. Go ahead, sign into Delta Math, get the assignment done. If you're falling behind, let's get caught up. I will be kind of gracious because the start of this semester has been a bit of a mess with me being out, but we got to get caught up. We got to get going because the semester is moving along and we got to keep up. So hope you guys have a great day. Talk to you later.